Okay, so we've looked at linear equations written in rate of change form, which is sometimes called slope-intercept form. So rate of change form we know is y equals mx plus b, where we've talked about m being the rate and b being the initial value. Sometimes this is called slope-intercept form because the rate is also the slope of the line. So the rate of change can also be described as the slope of the line in terms of how steep the line is. So sometimes it's called slope instead of rate of change, and b is the initial value, and we know that occurs when x equals 0, and all the points that have a value of x being 0 are on the y-axis, so sometimes they're called the y-intercept. It's where the point intercepts the y-axis. So sometimes our y equals mx plus b equation is called the slope-intercept form. We can also write our equations in standard form. So standard form is ax plus by plus c. You'll notice that there's still only one x and one y. So any linear equation can be graphed if we have 2 points. So if we have an equation in standard form, we can find 2 points quite easily. So here in standard form it's 2x minus 3y minus 6 equals 0. In standard form, you'll notice that the equation equals 0, so everything's on one side. There are no fractions. So no fraction coefficients. And the coefficient of a is always positive. Okay, so how do we find 2 points if it's in standard form? Well, we can find 2 points that are on the axes. So we can find one on each axis. So if we want to find a point on the x-axis, all the points on the x-axis, y is 0. All the points on the y-axis, the x will be 0. Okay, so if you think of this graph, this table here, every point on the x-axis has a coordinate of x is 0, or y is 0. So this point is 1, 0, 2, 0, 3, 0, 4, 0, and so on. So we can use that information. So on the x-axis, oops, don't want that. On the x-axis, y equals 0. On the y-axis, all these points have a value of x is 0. So how can we use this information to find a point? So we can let x equal 0 and find y. So if I let x equal 0, then that eliminates that value there. 2 times 0 is 0, which leaves me with just y. And then we can solve for y. So let's do the opposite of minus 6. We'll add 6. And then we'll divide by negative 3 to find y. So y equals negative 2. So that means that when we put x was 0, y was negative 2. And so that's 1 point that's on the y-axis. Then we can let y equal 0 and find x. So this time we're going to let y equal 0, and we're going to find x. So that eliminates that term, because 3 times 0 is 0, which leaves me with 2x minus 6 equals 0. We can add 6 to both sides to get rid of the 6, and then we can divide by 2. So that gave me a point for when y was 0, x was 3. So that's going to be here, 3, 0. And once I have 2 points, I can draw the line. That's all I need. I don't need any more points than 2. I could count the rate of change to find how I got from one point to the next. So I went up 2 over 3, so I could continue that. Up 2 over 3 would be the next point, and so on. Up 2 over 3. So I could find more points once I find 2, but I really only need 2 points to draw a line. So we can use our x-intercept, which is the point on the x-axis, and we can use the y-intercept, which is the point on the y-axis. I can see if this is correct. So the point was 2x minus 3y. We could also change to slope-intercept form. So if we take the same equation, so minus 6, so we could also change it to slope-intercept form. So that means you want to isolate for y. You want to get the y by itself. So I can move this 2x to the other side, and I can move this 6 to the other side. So we just do the opposite, which would leave me with minus 3y equals minus 2x plus 6. And then I just want y, so then I would divide by minus 3. So y, negative 3 divided by a negative 3 is 1. So 1y equals a negative divided by a negative is a positive. And then 6 divided by negative 3 is negative 2. So I've put it in slope-intercept form, where 2/3 is the rate of change, and negative 2 is the initial value. So negative 2 is the initial value, which is on the y-axis, 0, negative 2. And then the rate of change is up 2 over 3, 1, 2 over 3. And I could continue that to find more points. So that is the second method. So the first method is find the x and y intercept. The second method is change to slope intercept, and then use the initial value and the rate of change to graph. Okay, so let's look at both methods here. Method 1 is find the x and y intercepts. So if I want to find the x-intercept, I'm going to set y equal to 0. If I want to find the y-intercept, I'm going to set x equals 0. So starting with 3x plus y minus 15 equals 0, I'm going to let y equal 0. So we'll replace y with 0. So that get rid of that term. And then we'll solve for x. So we'll do the opposite of minus 15. We'll add 15. So 3x equals 15. And then we'll divide by 3. So x equals 5. So we have 1 point when we set x or y to 0, we found x to be 5. So there's 1 point on our line at 5, 0. And then we'll do the same with the y-intercept. So in order to find the y-intercept, we're going to let x equal 0. So we'll replace x with 0, which gets rid of that term, and that leaves us with 5y minus 15 equals 0, and then we're going to solve for y. So we'll add 15, we'll do the opposite. So 5y equals 15, and then we'll divide by 5. So y equals 3. So when x was 0, y worked out to be 3, which is right here. Once we have 2 points, we can make a line. So there is our line. Or we could do method 2. We could change to slope-intercept form. So the equation was 3x plus 5y minus 15 equals 0. So I'm isolating for y. So I'm going to move the 3x to the other side and the 15 by doing the opposite. So that gets rid of that, and we're left with 5y equals negative 3x plus 15, and we want y, so we'll divide each term by 5. And that leaves us with negative 3 over 5x plus 3. So the initial value is 3. And the rate is negative 3 over 5. So the initial value is 3, which we already see here on the line, and then we go down 3 over 5 to find the next point. So both methods are fine. You will be specifically asked to do each one. But the x and y intercept is just another way to graph by finding 2 points. Okay, let's do this one. So I'm going to find the x-intercept by letting y equal 0, and then I'm going to find the y-intercept by letting x equal 0. So it's not technically in standard form because the 6 is not on the left, but that's okay. We'll do it the same method. So we're going to let y equal 0, which gets rid of that. So x will equal 6. So that point would be when y is 0, x is 6. That point is right here. And then we'll do the same with this equation. We'll let x equal 0. Which gets rid of that term, and then we'll divide by negative 3 to solve for y. So when we let x equal 0, y equals negative 2, which is right there. And now we have our 2 points that are required to make a line. Okay, here we have a word problem or application. So it is a banquet hall that is going to charge per person and then also for the hall rental. So this one wants us to write the equation in slope-intercept form because sometimes that's more logical to do. So if I want it in slope-intercept form, I have to get the y by itself. So move the 2x to the other side and move the 200 to the other side. So negative y equals negative 2x minus 200. We don't want negative y, we want positive. So we'll divide by the coefficient of negative 1 so that we get positive y. So now we have it in slope-intercept form. So remember that 2 is the rate of change, which is the cost per person. So it would be $2 per person is the rate of change. And then the fixed cost is $200, right? That's this cost. And what that might be for, that might be for the hall rental, which is in addition to the cost per person. So once we have it in slope-intercept form, it's handy because then we can use this equation to find the cost for 125 people or any number of people. So each person costs $2 plus 200 fixed cost. So that's $250 plus 200 is $450. So it would cost us $450 if we wanted to have 125 people attend the banquet. And we can also use it to find how many people could go if we had the price. So if the total cost was $920, we could determine how many people went to the banquet. So that's why the slope-intercept form is sometimes handy because it allows us much easier to use it for solving other questions. So we'll divide by 2. And we get 360 people. So sometimes the Y-intercept method is useful for just graphing, and then sometimes the slope-intercept form is useful if we're asked certain questions about that application.